Hey everyone, we are looking today at writing the equations of differentials and antiderivatives. So first let's talk vocab. So when you see that word differential, you might go, hey, that looks kind of like the word for derivative, and why are there so many words for derivative anyway? Derive, differentiate, now we're adding another with differential? Yeah, so be it. Anyway, so we have a couple clues though. Besides the fact that that word looks a lot like some of the other words for derivatives, but we have this dy. It's like, well, that looks kind of like dy dx. And it basically is. Writing the equation of a differential, it's just taking the derivative and moving things around. We'll get more into the meaning and some of the subtleties of what this is all about later, but for now, let's just deal with the mechanics. So that's all we're worrying about for this time, for this period of time. So if you have y equals 5x to the negative 3, the equation of the differential will be dy equals, and then we'll just derive like usual, negative 15x to the negative 4th. And then, hey, where did dx go? We'll just put it at the end. It's not really just putting it at the end. You could consider it kind of like a chain rule thing of like the derivative of x is dx, that derivative of our inside. You could also think of it as just simply if you have dy dx equals, then to get it so it's just dy, you can essentially multiply both sides by dx. It's not quite precisely what we're doing, but for all practical purposes, it is. So let's look at another one. If we have y equals this 4x squared plus 9 in parentheses to the 8th, so dy. This is really great derivative practice, by the way. You might have noticed that. And the chain rule won't go away. Derivative of the outside, so we have 8, keep the inside the same, 4x squared plus 9 to the 7th times derivative of the inside, so we have a times 8x, and then dx. No big deal. Okay, and then for this guy, we have x squared plus sine cubed 3x. I am going to do a quick rewrite of this, just as a reminder that what this really means is an x squared plus sine of, I'm going to even put the 3x in parentheses, cubed. So we have that guy. So finding the differential, dy equals, we have 2x as usual, and then plus we have derivative of the outside, so the 3, keep the inside the same, sine 3x squared, and then derivative of the inside, so the derivative of sine 3x is cosine, keep its inside the same, 3x, times derivative of the inside again. And then finally, that dx. And here is where the mistakes are made, so watch out for it. Just like when you're doing times derivative of the inside and it's like with a plus in there, we need parentheses around that because the whole thing is getting hit with the dx. Okay. So that's finding the equation of a differential. For all practical purposes, it's just derivatives. So you're going to get some great practice on that today. And then the next bit is finding an equation for the antiderivative y. Well, antiderivative, there are other words for it, but we're going to ignore the other words for now. So one thing to note is the word an equation. It's not the equation, it's an equation, which is kind of weird. There are actually infinitely many equations that fit this differential. And we've seen this before. So basically, we're doing the exact opposite of what we just did. So the derivative, or the antiderivative, so we get y equals, and then we know from using our product rule, our power rule, add 1 to the exponent. If I derive x to the 5th, we have that times 5 show up, so we divide by that new exponent, just a reminder. And I don't need to make this pretty. 36 over 5 x to the 5th is totally fine. Now here's where that an equation comes in, because I don't know if this guy had like some sort of vertical translation. It could have a -8 or a +10 or whatever. I don't know that. So what I do is plus c. And C is for constant, so that's the letter that gets used there. It might get used for plus cat, which is yelling outside the door. I don't know if you can hear that. Probably not. Anyway, one thing that's nice about doing antiderivatives, if you're doubting yourself, just check your work by deriving it. And if I take the derivative of that, I do get back to where I started. So you can always check your work. And I recommend it. I also recommend that, the list that we have, your life is going to be so much easier if you have those rules all in your head. Get those memorized. If we were actually in the building, your tests would be without notes. You would be doing things totally on your own. It would kind of be rough, but it's actually, faster and you'll be more efficient. And efficient is good. Okay. dy equals cosine 0.2x dx. So I have y. And remember, when you're doing these antiderivatives, you say, what has a derivative of? What has a derivative of cosine? Well, sine does. And then remembering the chain rule, do insides change? No, they never change. I would have a 0.2x not changing there, because remember that is technically a parentheses there. But now, if I were to take the derivative of this, I would get cosine 0.2x, and then chain rule would mean a times 0.2. So I can do a 1 over 0.2 in the front. I know I could make that prettier, but I'm not going to, because I don't really care that much. Dividing by 0.2 is totally fine. You could also put the whole thing over 0.2, totally fine. And then also, because it's an equation, we don't know the vertical translation, if any, we have a plus c. Okay, this is where having that derivatives list in your head is really, really helpful, because this is trickier, and so many of you are gonna want to go, oh, I'll just add 1 to my exponent, no big deal. Remember that this is actually, you said, what has a derivative of cosecant squared stuff? Well, that's cotangent-ish. Okay, I'll get to the ish. So cotangent has a derivative of cosecant squared. Oh, but wait, cotangent has a derivative of negative cosecant squared. So I actually need to make this guy negative. Because now if I do the derivative of negative cotangent, I would get a positive cosecant squared. And then I keep going and I say, do insides change? Nope. Much like human nature, insides don't change. And then finally, if I were to derive this negative cotangent 3x, I would have a times 3 show up from the chain rule. So I need to get a 1/3 there. I'm actually going to go like this, 1/3, and I'll move my negative. Haha, sneaky. Be really careful that you don't do like a 1, if you don't write this, because that would be really wrong, because that's saying 1/3 minus cotangent. No, don't do that. If you do it, throw a multiplication dot in there, or better yet, do it in kind of the more standard order. And then finally our plus c. And again, you can check your answers by deriving. Check answers by deriving. Technically, when you're checking your answers by deriving, you are finding the differential, but it's kind of the same thing. Anyway, that is our equations for antiderivatives. These will always feel harder than finding a derivative or a differential. That's just kind of the nature of the beast. But when you're unsure, check that answer.